This is TechCrunch. The way in which we humans alloy metals is essentially the same today as it was back in the Bronze Age. You melt some different metals in a pot, you mix them until they form a new, better metal. Well, an early-stage startup called Foundation Alloy has developed a new alloying technique that beats the ingredients instead of melting them. Jake Guglin, co-founder and CEO of Foundation Alloy, told TechCrunch, we're actually smashing metal powder particles together instead of melting them. We can create properties that other people cannot. So far, the startup has been selling its bespoke metals in small batches, but Guglin said his company is constrained by our ability to make stuff, not by the people that want to take it. Judging by the types of industries Foundation Alloy is selling into, it seems everyone wants better existing metals or entirely new ones. Guglin said that the startup is running pilots with companies in the automotive, aerospace, semiconductor, and defense industries, along with others that make chef's knives and luxury watches. He said, "We can save them tons of money and tons of waste." To scale up production to several tons per week by 2027, Foundation Alloy has raised a $22 million Series A round led by Voyager Ventures. Also participating in the round were Trust Ventures, Yamaha Motors, America's Frontier Fund, Overlap Holdings, Material Impact, Engine Ventures, LCAP, and Kanematsu Corporation, which will also distribute the startup's metals in Japan and Southeast Asia. Foundation Alloy's technology emerged from scientific research conducted over the last 20 years. Tim Rupert and Chris Hsu led efforts to understand what happened to metals at the nanometer scale, which formed the basis of Foundation Alloy's technology. Hsu is no stranger to the startup game, having previously co-founded Desktop Metal and Xtalic. Where nearly all alloys used commercially today are made by melting different metals, Foundation Alloy uses a special type of mill that repeatedly smashes different metal powders together until they become one new metal. By eschewing melting, Guglin said his company's solid-state process uses around an order of magnitude less energy. The goal of an alloying process is to create a molecular-scale crystalline structure that blends two or more metallic elements. A perfect alloy would be completely homogeneous. That is, every crystal pattern would be replicated consistently across the entire metal. Traditional alloying does a reasonably good job of achieving that, but it's not perfect, leaving voids that can reduce the performance of an alloy, making it more brittle or more susceptible to heat. The traditional method also does not work for metals with vastly different melting points, meaning that there have been entire classes of metal alloys with potentially beneficial properties that we haven't been able to make. The solid-state alloying process allows Foundation to make materials that solve some age-old trade-offs. Traditionally, metals are tailored to withstand heat or mechanical stress, since trying to do both usually results in a metal that's not good at either one. Metals used in furnaces tend to be brittle, while stronger ones used in tooling to make things like car parts tend to break down faster when exposed to heat. But Foundation Alloy has been able to solve that problem, making metals that can take the heat and take a beating. Some of its first products have been tooling parts for automakers, as well as aerospace and defense companies. With defense, one early market is parts for drones, where some of the supply chains were originally designed for F-35 fighter jets. Guglin said that they think about making 100 perfect parts per year, whereas drones need more like 10,000 per month. Alloying is akin to cooking, Guglin said. Two different chefs might use the same ingredients, but produce dishes that taste differently, for better or worse, if they don't follow the same procedural steps. Guglin said the quality of the output of a dish is not just based on the ingredients, it's how you cook it. We have a new way to cook. As LLMs have grown more powerful, hallucinations have proven stubbornly difficult to avoid. Errors pop up in even the smartest models, and while there are ways to catch those errors, the industry is still figuring out the best way to do it. Probably, and that's the name of a company, Probably, which just raised $9 million in seed funding from Andreessen Horowitz, is trying to build a more rigorous way to catch those errors. As founder Peter Elias puts it, the company's goal is to prevent hallucinations and simple factual errors from ever reaching the user and achieve the kind of 99.99% accuracy that's common in deterministic systems, but much more difficult to reach with AI. As it turns out, bringing LLMs to that level of accuracy requires rethinking many of the basic assumptions of AI engineering. Probably's first product is a data science tool built to produce quick answers for complex data sets. Each result comes with a citation and an audit trail for how it was deployed, an increasingly common practice among AI tools. But keeping errors from creeping into those summaries required an elaborate harness system that Elias describes as a data science mech suit. The LLM's first-pass answers are checked against a deterministic validator system, which bounces back any results that don't match the dataset. Crucially, the company said that the LLM has been trained against the validator, and the whole system is optimized for fast and accurate answers. Elias continued that what we learned building this was that the better your harness engineering is, the weaker the model can be. If you can refine the context enough, the model does not have to work very hard to do the right thing. Basically, it's an exercise in reducing ambiguity. That allows Probably's data science tool to run on significantly smaller AI models. Elias says the current version is running on a model that's 4 classes weaker than the frontier models, which means it can be run on local hardware. That's a desktop computer instead of a data center, which reduces a huge amount of the token costs associated with AI use. It's a welcome idea at a time when token costs are rising and many customers are reassessing their AI budgets. And Elias's idea doesn't end with data science, as the same engine can be extended to cover use cases like accounting or medical services, as Elias puts it, any precision-sensitive use case. I think it's really interesting that the big AI labs have not even attempted to do this, Elias said. They're incentivized not to, because they make money the more times you have to correct the model. That's all for now. For the latest tech news, go to TechCrunch.com.